In this section, you're going to learn how to use similar triangles in a special situation. The special situation is you start out with a right triangle, and then in that right triangle from the vertex, so for example the vertex here would be Q, from this vertex, well, never mind. So from the vertex Q you draw another altitude to the hypotenuse of the original triangle. We'll call that S. And what happens is you get two small triangles within the big triangle, and all three are similar, and let's see why. Okay, so let's look at triangle S or Q, which is this one here, and this is angle R in the original triangle. I'm going to mark it over on this triangle here. This is the original triangle, and so angle R in the little triangle here is congruent to angle R in the original. So the two, oh, I forgot this. Right, let's fix that. So now we've got triangle S or Q is similar to triangle Q. R is common, R. And just to make it simpler, we draw them in the same orientation, but even if you don't, you can look at the angles that are congruent, line them up, and you get your similarity statement. Then we look at triangle Q, P, S, and angle P is angle P, original triangle, is congruent to angle P in triangle QSP. Again, they have been drawn in the orientation so that you can see the angle congruency and see the corresponding sides in the same orientation. So the way we write the similarity statement now is, okay, so let's look at triangle QRP and this triangle here. So angle Q and S are right angles. Angle P is congruent to itself. That's this. And so the remaining letter is Q. Okay, so now that we have our similarity statement, we can come up with, I'm going to erase these because I want these later on. We can write statements of proportionality. So first we will look at the first two triangles, and I get SR over QR equals RQ over RP equals SQ over QP. Well, do you notice something here? That in the first two, RQ is repeated, and if you recall, this is a geometric mean. When in a proportion you have a variable that occurs twice, so RQ is the geometric mean, and this is a leg of this original triangle. The leg is a geometric mean between SR, which shares a vertex with QR, and RP, which is the whole hypotenuse. You will see a theorem relating to this later on. Now let's look at the second and third triangles, and we'll write our statement of proportionality again. So we get QR over SQ equals RP over QP equals QP over SP. Well, look at this. We get another geometric mean. And QP is the other leg of the original triangle, and it is the geometric mean between SP, which shares a common vertex with QP, and the whole hypotenuse, which is RP. So these two, this is a situation here, hello, okay, where the leg is a geometric mean. So now we're going to look at these two triangles, the top ones, and we're going to write a statement of proportionality, and we'll write it in different colors. SR over SQ equals RQ over QP equals SQ over SP. So let's go hunting again. Do we see a geometric mean? Do we see a geometric mean? Hello. Aha. It was not so obvious to begin with, but I see it here now. So there is SQ and SQ. Now SQ is an altitude of the original triangle, the altitude that we draw from the vertex to the opposite hypotenuse. So let's see. The altitude is a geometric mean between the two parts of the original hypotenuse, which is RS and SP. Okie doke. So with this information, let's see if we can solve a problem. So we're going to make up some numbers here. Alright, we're going to make up some numbers here. Let me see if I can do it this way. Yes, I can. I'm going to make this a little bit smaller. A little bit smaller again. Alright, that'll give me enough room. So what I'm going to do is, let's say I have a situation in which I am given a right triangle and an altitude. So this is Q, S, R, P. Okay, and this time you are actually given the lengths. So RP is 9, and you are asked to find Y. So since this is a right triangle with an altitude, you ask yourself, oh, it's a leg. The leg is the geometric mean between the part of the hypotenuse that touches us and the whole hypotenuse. And if you want to write your equation where Y is the geometric mean, remember, Y needs to go in the means position, and it is the mean between 3 and 9. So when you cross multiply, get Y squared equals 3 times 9. Take the square root, and you get square root of 3 times 3 times 3. Remember, for each power, it comes at the radical, so the answer is 3 root 3. So I've given you a little overview of similar right triangles. When you start with a right triangle, an altitude is drawn from the vertex containing the right angle to the opposite hypotenuse. So go ahead and take notes on this section and work the problems out at the end. It is very critical that you practice This is a little tricky, but once you get the hang of it and you practice enough, you'll be good at it. Okay, good luck.